the world the Lord has come. Let earth receive her King. Let all hearts sing him room. And heaven and nature sing. And heaven and nature sing. And heaven and nature sing. Today we will be looking at limits. So we changed the background to a grid in order to help with drawing the graph. So what are we doing? Well, I should have done this a long time ago. Oh my God! But today we will be reviewing what a limit is. So first, let's see, what is a limit really? Well, let's say that you have a point where something is undefined, like at this point, which is minus 11, comma minus 7. Or is it really minus 7? Because it's undefined. But if we take something really close, like over here, we'll find it to be minus 11, comma 9.99. Or rather, 6.99. However, so you get farther and farther, but as the y value gets closer, you start to get this estimate of what it could be. So for example, let's say you're at this point over here, which is minus 20, comma 10. And so now you're over here. And so your y value is 10. But how can you predict what the y value is going to be over here? So instead, you go one more down the path. And suddenly you have a point over here, which is at negative 17, comma 9. Now you've gotten closer somewhat, but you're still not close enough. What about here? This is negative 14, comma 8. We're getting close, but not close enough. This would be, so actually, this is descending and descending. I just realized this should actually be 7.01 or something. So 8, and so this should be 7.5. So as we get closer and closer to the x value of negative 11, then the y value gets closer and closer to 7. So, what do we say? Well, even though if we take f of negative 11, it's going to be undefined, the limit of f is x approaches negative 11 will be equal to 7. So, this is what a limit is. But that's just a two-sided limit. Get ready for some fun. So, what about this point right over here? Or rather, 2 points. You have this one point, which is, let's see, where is it? Negative 5, comma 5. Then you have this point over here, which is at negative 5, comma negative 2. Okay. So, this is what we have so far. So minus 5, comma 5, minus 5, comma minus 2. But we have 2 points now. Think of this as a teleporter. So it teleports you. This teleports you over here. And once you go back here, it takes you back over here. Poof! It's kind of like the teleporter we used to get to the forest in those projectile motion videos. Anyway, what do we do over here? Well, we realize that as we get closer and closer from the right, then as we get closer and closer from the right, then we get the answer negative 2. That's what it should be approaching. But when we approach closer and closer from the left, we get the answer negative 5, right? So, or actually rather positive 5. This should actually be on depth. over here is minus 4.9, comma, say maybe, okay, let's say it's minus 4.9, you have positive 4.9, say. And so, that's right next to 5, comma, minus 5, comma, undefined. That should actually be, so let's say you have this point, that is minus 5.1, comma, 4.9. It gets closer and closer to minus 5, comma, 5. But from this side, it gets closer and closer to minus 5, minus 2. So you have two limits. The one over here you get is the limit as x approaches negative 5 should be equal, oh goodness, I didn't write of x, should be equal to 5, like what we see over here. But when we look in the other direction, we get the conclusion that as x approaches negative 5, f of x should approach 2. That's quite strange. So what do we use to break these two up, differentiate them from one another? Well, the one on the left we just put a handy minus over there. The one on the left over here, we just put a minus. We put a plus on the one that's on the right. So if we're approaching here towards the right and from the left, so if we are approaching in the right direction, then we put a negative over here. But if we're approaching in the left direction, then we get the positive sign. That's what we use. And what are these types of things called? They're called one-sided limits. Because they are not the same on both sides. They only apply to one side. And so, now, let's look at our final anomaly over here. Around the number 4, these two guys seem to never be able to hit it. It's kind of like when you take it's kind of like a fire. You get closer and closer, but you're not going to touch it. Or kind of like the slap paradox that we did in the Bronx. Wink, wink. That's for Bronx. Wink, wink. Where if you have a man, presumably the guy who asked that question, so he looks kind of like this. His name starts with an R and ends with an H. And so, if we took this deranged looking man and had a hand that have the distance between it and his face every single time. So, boom, now it's twice as close. Boom, now it's twice as close again. Boom, now it's twice as close. But every single time, it keeps getting less and less closer. So, it will never touch this guy's face. It's unfortunate. And so, let's erase this deranged man from the scene. And now, we're going to look at the same thing over here. Now, the vertical asymptote is where these guys are headed, but will never go. So the vertical asymptote, I think I can draw it using this line over here. So it won't be much visible at first. It won't be very visible at first, but I promise that it will get more visible. That's not what I wanted. Sorry. What the? I did not like that sound. But there's the vertical asymptote. Now I'm going to change its color because it looks weird. Oh, goodness! Oh, yeah. Okay. So this is the vertical asymptote. And as you can see, it's on 4. So they will get closer and closer to this asymptote continually, but they will never ever touch it. Ignore that. That's just an inaccuracy because my hands are screwed up. So what is the limit of, oh goodness. So say, what is the limit of f of x as x approaches 4? That, my friend, is undefined. And it's undefined on both sides. And so, even if you get closer and closer to it, you will never be there. Because we realize that this cannot intersect with the vertical asymptote. If it will intercept somewhere, that somewhere will likely be infinity. And infinity is not a number, is it now? And so, now, this is the definition of a limit. Ignore that over there. And so, now, what is the limit of a very special kind of case? A kind of case I would like to call a composite function. F of g of x. So let's say that the limit of g of x as x approaches this constant c is this random number, roulette wheel for letters, ding ding ding, a. So we get a over here, and so now the limit of f of g of x, is the limit as x approaches to c of f of g of x will be equal to, this limit applies in the interior, so we get f of the limit of x of the approaches c of g of x is a, we see that, and eventually we just get f of a. So the limit of x approaches c, the limit is x approaches c of f of g of x is f of a, given that the limit as x approaches of c of g of x is a. So that's all we have today for limit, and we'll see you tomorrow. This is a pretty advanced looking graph, not gonna lie. See ya! Bye!
Brought to you by Brilliant.org.
Bari Science Lab to fall in love with math and science.